Now that you have created your puzzle pieces in Inventor, it is time to put them together in something called an assembly file. If you recall assembly files, there's another type of file, a type called the .iam file. We use it as an assembly point so we can put everything together. So the first thing I'll ask you to do is go ahead and launch Inventor 2013, and it'll come up. You can select New. This time, instead of making a new standard IPT part, instead you're going to select standard IAM. This is a little different than, say, mold designs or well designs. This is the default one, the most common one used when it comes to assembling a product in Inventor. You'll click on that and you create, and you'll get your toolbar. You'll get your browser bar window on the side. But notice your toolbar is no longer the same kind of toolbar used to create sketches and then model pieces. This is an assembly toolbar. This is, you're no longer creating parts, you're now going to put them together. You still have your standard workspace, you have your isometric cube, browser bar. The only thing is you're not creating pieces, you're pasting them together. And with that, we go to our very first component. Instead of what used to be create 2D sketch, this is place component. This tells Inventor that we're going to take a piece and from our folder, in this case my sample puzzle cube, and we're going to go through our piece and decide which of these will be our starting point. Which of these pieces is my first part. The way Inventor creates assembly files, the first piece will become a reference point and it'll be effectively grounded in place so it can't move. Typically for my puzzle cube, I always like to start with this piece when I put it together. So I'm going to say this is my part 1. Whichever piece you pick up first when it comes to assembling your cube, whichever piece you go for first, that typically should be your part 1, your first assembled part. So I'll click piece 1, hit open. I get this little warning saying that the original piece was made in professional registered versus the student version. I understand. You might get something similar to that if you have Inventor at home. And yes, I'll proceed anyway. And all of a sudden, there's my piece in front of me, but if you can see, it's got other options, other images floating around. The way Inventor works is you can put down as many pieces as you want. And then when you're done, you click OK. Obviously, I only need one of these pieces for this. If you go to my browser bar, it went ahead and updated all the piece numbers. It gave me, I have a total of 8 from here. I don't need 8. I only needed 1. So I can actually go through each one of them, hit right click delete, or I can click on hit the delete key, or I can even go from here and highlight as many of them as I want. And you can see them all highlighted and hit delete from there. And then home, and there's my original piece. So Inventor does let you put down as many parts as you want. In this case, I only needed 1 piece. So fantastic. A little note about your browser bar. Here you have assembly 2. Assembly 2 means very little to us. Instead, I'm going to call this sample puzzle cube. No sense in going generic nameless items. We're going to name as many parts as we can in Inventor browser bar so we can keep better track of them. Now, if I tried naming this here, see if it'll let me. No. It won't let me do it as easily here in Dart because this piece was created before and it was given the name piece 1, and the colon 1 indicates just it's the first of piece 1. They could have piece 1 of A, piece 1 of 2. This is piece 1 of 1. But I can't change its name. But notice this little symbol here. It looks like a safety pin. That indicates that this piece is grounded. It means it will not move. If I try highlighting it and then, well, let's not double click, let's return. If I try clicking on it and dragging across, you get what looks like your mouse cursor changes into a safety pin with a ground symbol next to it. This piece is reference fixed. If ever I wanted to change that, I can right click on the icon in the browser bar and take off the grounded. But for today, I'll leave it in place. Now, there's my first part. Let me go grab another one of my pieces. Piece 2 happens to be the second part. When I assemble my cube, yes, I understand it was made in student, professional, this is student version. And when I place it down there, you can see this piece is going to float around saying, well, how many do you want? Where do you want to initially place it? I'll place it right here. And do I need any more? No. So I'll click OK. These two pieces are floating in space right now. This one's fixed. This one I can move wherever I want to, even through the other piece. Of course, this is Windows. This is Inventor. It's a modeling tool. These are 3D representations. Nothing really exists, so it doesn't really freak out too much when you cross into its space. In fact, Inventor has no real concept of what this means. When one goes into another, it's mostly for visual or for our purposes. So let's do this. I need to make sure that this piece, for example, that this surface right here on the black elf piece is mated to or touches along with this inner surface here. Now to do that, we're going to use a tool called constraint. Constraint is a very powerful tool. It goes a long way to assembling everything for us in Inventor. In fact, I think everything is assembled with an Inventor. And as you can see from the little icon, you select it, you tell it how pieces go together, along what orientations, along what axes, and it holds your parts, your assembled pieces together. So we're going to tell it, you know what, we're going to click constraint, and then in our constraint window, it comes up with several little options, like, well, what kind? We need an assembly constraint for this project. We eventually have things such as motions for rotational gears, translational for things going across, other, I'm not sure what constraint set is exactly, but 90% of the time we'll use assembly. And within assembly, we have four types. There's mate, angle, tangent, insert. Mate is already the default one. It's the easiest one. It's when you want two surfaces just to come together face to face or come together flush. Now, we do just an example. Angle shows how pieces can come together at set angles, undirected, all sorts. Tangent works best for round objects, cylindrical objects when you touch at one contact point. Insert come in handy when we insert pegs into openings, into hole screws, into screw openings. But again, we'll go with mate, and we're going to click the one that's mate opposed to each other, face to face. And you can see the two little symbols here, the blue box and the yellow box are coming together opposing to each other, so they're facing face to face. The selections tells you which first selection, second selection. By default, the one in blue is set to go. That's the highlighted one. It's asking which is your first selection. I will go over here to the black L and say this surface. Notice how this gets highlighted. There's a red arrow over. That's my first selection. It automatically flips over to the second selection, and I'll tell it that face is going to mate to that face. And you get this odd little ubiquitous sound, and you're going, what happened? Nothing's touching each other. Huh? What? Oh, well, you know what we had? We had the wrong kind of mate in place. We had flush. Inventor will do exactly as you tell it to, whether you like it or not. It will do what it thinks you ask of it. And I had it set to flush. These two surfaces are now flush to each other. They're on the same geometric plane, if you will. Well, that's not going to help me much, so instead I'm going to switch it over to mate. Again, if I had it flush, it will find a solution that's flush. Ask it for mate, it will mate those two pieces. You heard the little bing saying we found a solution. It means Inventor found a way to mate this process. If there's no way to make that constraint, it will give you an error. You will see those coming up soon. And you'll say, okay, well, that looks like right. That looks like it should be right. Well, nothing's going to be applied until you actually click apply. This is the preview window at this point. You say, okay, this is what your mate's going to look like. Do you want it? Yes. I click apply. And then let me hit cancel for a moment. And if you look at it, it's like, well, that's not quite right. And it's true. The pieces are not in the right orientation. The two surfaces we wanted are mated together, so they're opposed to each other. But if I take the blue piece, I can still slide it away. I can slide it away, and it looks like it's moving freely, but in reality, it is not moving as free as it looks. It is bound on two planes. It is bound it is bound so that this surface and the respective surface underneath are always on the same plane. It means it'll slide back and forth, in and out, but it won't slide past itself. It won't go it. Even though it looks like I am, that's just an illusion from the perspective I'm at. Even though it looks like it's moving up and down against each other, it's just orientation we're at. Well, when it comes to assembling products, you will need to have, on average, typically, most of the times, 3 constraints. You have to lock down 3 degrees of freedom to make sure the part doesn't move. There was one. Let's get the constraint window back up. And we will go, you know what, we need a make constraint. We made it this to this. No need to try that again. Instead, I'm going to go for a flush. I'm going to say it'd be great if this surface and this surface were flush. And I hit apply. And I go close for now. And I see what I've done. I've locked down 2 constraints. Even looks like my piece is a lot less mobile. I can only move it along 1 remaining axis. I can no longer move it so that it looks like it's going all over the place. Now it's getting really restricted. And I'll flip it back on there, go back to isometric home for a moment. And I'll say, great, let me add another constraint. And I'll go, you know what, it'd be really great if I could make this surface with this inside surface. You hear the ubiquitous little bing. I hit apply, cancel the inspect. And now if you look, I'm trying to drag away the piece. I click and drag. You get the not allowed symbol or not possible symbol. My piece, the black piece is grounded. This one is locked in place because of the constraints. It's no longer possible to move this because you told Inventor that this piece attaches to this piece based on this constraint in here. And let me look at the browser bar here. We told it the browser bar, like when creating the part, the browser bar kept track of all your modeling features, your sketches, what you did with those sketches. In the assembly file, the browser bar keeps track of how the pieces are assembled. And you can see there's mate 1, was when we told those 2 surfaces meet together. There's flush 1, when we said those 2 surfaces are flush next to each other. And then there's mate 2, which said the inside of the blue piece against the inside of that black piece were made together. And those are all the constraints on piece 1. And if I open piece 2, you see the same constraints. Pieces that share constraints, they'll have the same name on here. I believe we can even rename these if we want. First mate, and it updates itself. This may be a little excessive because it may be a lot of descriptions going on, but this is one way to keep track of your constraints across the board. Well, now let's keep assembling. There's my 2 pieces. Once you understand how to assemble 2 pieces using constraints and get 3 of those constraints in place, then the rest of it just becomes adding more pieces and doing the same. This is my 3rd piece. My 3rd piece, well, I need this to turn around a little bit, and rotating the whole thing is sometimes not practical. I want to keep my view. There's the view I enjoy. So let's do this. I'm going to rotate this piece. If I click rotate and then click on the object I want, I can rotate this around. I happen to know that this piece could orient itself better this way, so I'll just click and rotate it. If I go to constraint, mate, flush, this surface to this surface, apply. Yeah, it looks horrible right now, but that's because Inventor found the quickest, cheapest, easiest solution. It only has 1 constraint right now, and with 1 constraint, that's what it meets. Now, if I add another constraint, it's going to have to rethink that solution to make sure it can fit. I know my pieces are flush to each other. And apply. Again, it still looks a little offset because Inventor say, those 2. That's the bare minimum I needed for now. How about this? I know that my pieces are flush here and here, and apply. I go to my object, my navigator window cube. I can't move it. It's locked in. That's my piece. I'm going to bring in my last 2 pieces. Place piece 1, and then OK, place piece 5, 1. In reality, you could place them all at the same time. You can open up your part, put your first piece down, and then assemble, put all the remaining pieces at the same time. I did this one by one to show the process one by one. But if you're comfortable, you can put down all your parts at one time and then assemble your cube as it was lighting before you. Let me do this. This piece, constraint. I need it to be flush. I need this surface, sorry, not flush, need opposed. This surface against this surface, and apply. And my puzzle cube actually works best if I then make this surface flush to the back, apply. Every time you make a constraint, you apply. Then here, flush with this on top, apply, and that fully constrains my purple piece. Last piece is this step piece. It fits right in here. I'll start by saying, you know what? Let's make opposed. That to that, apply. Oh no, it went through because, yeah, well, Inventor finds the best solution. It doesn't care if it shoves pieces into each other. That sounds terrible, but that's just Inventor. I want this surface flush to this surface. I don't think that's the right one actually. So I'll hit cancel. It'll go back to the previous. I want this surface flush to this surface. Apply. There's two constraints. The last constraint will sell the score here. Flush these two surfaces and apply. In the end, I have my completely assembled puzzle cube, and you will do the same. Now, in the end of the process, just like when you're making puzzle cubes, you make a mistake, you want to go back, you realize that's not the way it went. You saw me do a little bit of that. Along the whole point, these pieces are locked in place because of these constraints. But if I went and deleted, which you have there, the piece is still in place. It looks like it's fantastic, and that's one of the pitfalls when making an assembly file. You can maneuver these pieces and make them look like they're touching them, but then when you move something, it totally fails on you. It's mobile when it should be locked in place. It looks like it's in the right position, but it will move on you when you least expect it, and that's because the constraints were put in place. I say this only because as you going along the way, if you make a mistake, if you realize that's not where the piece went, you don't have to delete the whole piece. You can just delete the constraints, like I did. I'm going to go back so all my constraints are back in place. The undo key is wonderful for that. Other little tricks. If I needed to look inside somewhere, for example, this green piece here, piece 3, if I want to see what was inside, I can turn off the visibility of pieces. Not delete them, but make them invisible so I can see what's inside. The piece is still there, it gets grayed out, it's still part of the constraint, still part of the assembly file, has its constraints listed there. But I just went ahead and turned it invisible for the time being. I'm going to turn it visible again. Hello. Try that. I made it grounded. Let's try that again. Make it visible once more. Once you have your assembled cube, you go to iPro, save, put it in your flash drive folder. I'll put today's date, 1/01/14. Happy New Year. And then click save. It's going to, because these files came from a different folder originally, it's going to ask, you want to save these changes and its dependents? Yes, because they originally went from one place. I want to hit yes to all. And then click OK. Yes, and these pieces are being updated from Inventor 2008 to Inventor 2013, so data format has changed in my case. and you click OK. Not sure what that was. Once you have your first cube, you're ready to go. Start a second and your third cube. I'm going to go ahead and stop now.